Hello, welcome to ANS Solver. This is the fourth question of the paper. So we need to find the exact coordinates of the point on the curve where y equals to x over 1 plus ln x, at which the gradient of the tangent is equal to 1 over 4. So that means they are suggesting us, because they have used the word gradient, which basically means dy by dx, they have said our dy by dx is equal to 1 over 4. But for that, we need to first differentiate. So now, how do I differentiate something like this? X over 1 plus ln x. I use a formula or a rule called as the quotient rule. Okay, this is a very important rule to know, because a variable is divided by another variable. So how do I do something like this? I take my u as x, which is the numerator. I take my v as 1 plus ln x. Okay, now what I do is I take my u dash, which is basically my differentiation of x, correct, which is 1, and now I take v dash, which is the differentiation of 1 plus ln x. The differentiation of 1, you need to know, is simply 0, obviously, plus the differentiation of ln x is 1 over x, correct. So I get my v dash as 1 over x. Got it? Now I have a quotient rule formula which I need to use, which is basically vu dash minus uv dash over v square. So simple substitution, I can write this as 1 plus ln x into u dash, which is simply 1, minus u, which is x, into 1 over x, correct. This is what I can do, over v square, which is 1 plus ln x the whole square, okay, which is equal to simply 1 by 4. Okay, so now I can write this as 1 plus ln x, okay, minus, I know I can cancel the x here simply to get 1, okay, over 1 plus ln x the whole square, which is equal to 1 over 4. Okay, so now I can write this as ln x, okay, over, because 1 minus 1 will get cancelled, I can write this as 1 over, I know this is basically a plus b the whole square, which is basically a square plus b square plus 2ab. So I can write this as 1 square plus ln x the whole square plus 2 into 1 into ln x, which I know is equal to 1 over 4. So now I can write this as ln x over 1 plus ln x the whole square plus 2 ln x, which is equal to 1 over 4. So now I can write this as ln x equals to, or what I can simply do is I can cross multiply. Okay, so I can write this as 4 into ln x equals to 1 plus ln x the whole square plus 2 ln x. So now I can write this as 0 equals to ln x the whole square plus 2 ln x minus 4 ln x plus 1, which can be written as ln x the whole square minus 2 ln x plus 1 equals to 0, correct. Now if you see, this is basically a quadratic. So how do we solve quadratic? I can say let ln x be a. So I can write this basically as a square minus 2a plus 1 equals to 0, correct. Now what I can do is I can solve this on my calc. So on the calculator, what you can do is click on mode first. When you click on mode, click on 5 where equation is written. Then click on 3. So do this much. When you do this, you get 3 boxes here. So in the first box, what you do is put 1, which is the coefficient of a square. In the second box, put -2, which is the coefficient of a. And in the last box, put 1, which is basically the constant. So when you do that, and then click on equal to, when you do that, you get your a or your x. You can say a, you get your a as 1, and you get your a as, oh, you only get your a as 1. So you only get one variable. So now what you simply do is, you write this as, you know a is basically ln x, correct? It is equal to 1. You know one important log property which suggests that the log of b with the base a equals to c can be written as b equals to a raised to c. So I can simply write this as x equals to, I know the base for ln is e, is equal to e raised to 1, which is simply e. Now I need both my coordinates. So what I do is, I know I have my function which is x over 1 plus ln x, correct? I know that y equals to x over 1 plus ln x. So in the place of x, I can simply substitute e over 1 plus ln e. Now ln e is simply 1. So I can write this as y equals to e over 1 plus 1, which is 2. So basically these are my x and y coordinates. Okay, I write this as e comma e over 2. This is what I can write. Okay, now we are done with the sum, understood everything. But now I just want to ask you one thing. If they would have said here that this is the gradient of the normal here, let's say they would have said normal, then what you would have done? Because see, now there's a concept of tangent and normal which you would have done in AS level also. It basically means tangent is the same gradient as stated, but the normal becomes the opposite and reciprocal. So basically, if they would have said that this is the gradient of the normal, you would have equated your dy by dx to -4 here. Okay, because it will become reciprocal, which becomes 4, and the opposite sign, which becomes -4. So this is an important concept to know, which I wanted to mention it to you, so that later when they ask it, you know how to do it.